it's often best to introduce a coordinate system and treat vectors algebraically. We don't always have vectors that we can graph and do addition and multiplication based on making a vector on a graph twice as long. So being able to use or treat vectors algebraically will actually give us a means of being able to manipulate and work with them. Now, if we place the initial point, which is the tail of a vector, at the origin, and we then make the terminal point of A, the terminal point then has coordinates A1, A2, and R2, and A1, A2, A3, and R3. So let's go ahead and I'm going to establish a coordinate or my axes here real quick. So let's just say that I'm going to work in R2 right now because it's much easier to draw in R2 than it is in R3. So this is my origin. Here's O, my origin. And I have this vector A, and consider A to be, these brackets denote a vector 3, 2. This is saying that this is my A1, A2, or in this case, this is my X and Y coordinate. So if X is 3, 1, 2, 3, and Y is 2, 1, 2, then this point of the vector is right there. So vector A goes from the origin to these coordinates, which consist of the point 3, 2. Now these coordinates are referred to as the components. Of A, remember A, these are all vectors. So this is vector A, and I'm going to say it goes from O to P. I'm going to make this point right here, point P. And point P has coordinates 3, 2. Now, I'm going to put some other vectors on here. I'm going to take a vector, I'm going to say it starts right from here, whatever those coordinates happen to be, and goes to here. And say another one down here, and it goes to here. Let's just say this is, I'm going to make this Q and R, and how about point S and point T. So what we have now are 3 different vectors. We have the vector that goes from Q to R. Actually, I didn't want that. And I have the vector from S to T. The order is extremely important because it tells me what direction I'm going from Q to R versus R to Q. And then I have the vector OP, which is actually vector A. Now, all these vectors shown are actually equivalent vectors. They're equivalent to A because they all have the same displacement. Every one of these, I moved over 3 and up 2, over 3, up 2, over 3, up 2. The displacement is identical. Their locations are different, but the displacement is are all identical. Now, the specific representation from the origin to P, this one right here, is called the position vector of point P. So vector A is the position vector of the point P, and P has coordinates 3, 2. Now, position vectors start at the origin and they go to the point that we're talking about. If I were to take a vector from the origin to say point T, and I call this vector, say, B, then B is the position vector of point T, whatever point T coordinates actually are. So what it's saying is this vector goes from the origin and it ends at the point T. So it's giving you actually the position of the point T. Now, we think of the equivalent vectors as simply being representations. All these, not this one, skip that one. All these others are representations of the vector A. So QR, ST, OP, they're all representations of the vector A.